Welcome everyone to this presentation today from the RSS Statistics in Sports section. It's celebrating both the Women's World Cup, and then we're running a prediction competition to celebrate that competition as well. So thanks to everyone for joining us live, and thanks for everyone who's watching at a later date. So the outline of the session today then is I'll do a quick introduction of the competition, super fast, and then we'll hand over to two fantastic speakers today who are going to talk about modelling women's football scores specifically, which you'll see why when I discuss the competition in a moment, why that's so relevant for us today. So let's get cracking then, introducing the competition. So the RSS Statistics in Sports section has run two previous prediction competitions. This is becoming an annual event. So the first one was for Euro 2020, which was actually held in 2021. So that was predicting all the outcomes of the matches at Euro 2020. And then the second iteration was predicting results of matches for Wimbledon 2022. And this year, we're predicting the outcomes of matches at the Women's World Cup. So we really like it. The idea this year is that it's sort of fusing ideas from the past two competitions. So we've got football from the first competition. And then we had, when we were predicting Wimbledon, we were predicting both the men's and the women's results. So again, we've got that. Is there a difference between modelling men's and women's sporting events? Hence our speakers today. So here are just a quick run through of the rules. So the goal of the competition is always to make probabilistic predictions of the outcomes of every game at a tournament. This year, that tournament is the Women's World Cup. So because the deadline is you've got to make your submissions before kickoff of the first game. So the idea is that you've got to make predictions for all the group games that we know are going to happen, and then every possible knockout game that could happen as well. So you do your predictions before the competition starts. We're looking at the results of all the matches, so that means you've got to predict everything that could ever happen. You're free to use any data that you wish, so that includes scraping from websites, things like that. It's just as long as it's publicly available. Okay, so this is just so that people like we've got people joining us today from Smart Odds. They can't get an advantage by using data that's behind some sort of paywall. Okay, so we're all hopefully on a level playing field with this. And then the idea is that you submit your code in your data or links to the data if the data sets are large, used to generate those predictions in your submission, so that we can just verify your results and check everything's all good. You can enter as an individual or a team, whatever works best for you. And there's some prizes available that relate to that, which we'll talk about in a moment. And finally, you can update your predictions at any point before the start of the competition by just submitting a new entry. And then only the most recent submission will be the one that goes forward as your submission. And you submit your entry by emailing that to the RSS website. More on that later. So we discussed the prizes earlier. There's three available. The first one is for the overall winner. That's the entry with the best log score. So you've made all your predictions, and we use something called the log score to see who the winners are. I won't talk about the log score today. All the information that you need is on the Github website for this competition, and I'll give you a link to that later on, and I'll bob that in the chat. So overall winner. Then we also have a methodology prize. This is chosen by the judging panel, and it's based on the methods that you used. Again, this is why we ask you to submit your code and your data as well in your submission, so that we can make that judgment. And then finally, new prize this year, the student prize. Again, this is awarded by the judging panel, and we're going to base that on a combination of the log score and the methodology used. So an entry where at least one team member has got e-student membership of the RSS. So if you're an individual and you've got e-student membership, you're absolutely fine. If you've got a team and one person in that team has got e-student membership, then you would qualify for the student prize. So again, when you make your submission, if this is applicable for you, if you're up for the student prize, then make sure you tell us that in your email as well. And then the prize for those three winners is that you get invited to present your work. So tell us about what you did at the 2023 RSS conference, which is in lovely Harrogate, and reasonable expenses are paid courtesy of Smart Odds. So we've got some Smart Odds representatives here today. They are the sponsors of the competition. So like I say, I've just briefly gone over things today. I would encourage you to visit the Github site. Again, I'll post a link to that in the chat later in this session. Because there you'll see the rules that I've gone through with you there. You'll see information on the scoring, how that works, that log score, the prizes, how to make a submission. So again, the email address and what you need to do there. There's also a fantastic section that I can't take credit for, one of my colleagues has created on getting started. So they've added an IPython notebook that describes fitting a model to a publicly available data set and producing some predictions in the correct format. So that's to help you get started. So I've been working my way through that, and it's absolutely fantastic. So I can't recommend that enough. There's also a section on getting in touch, and then right at the bottom, there's some suggested resources. So some data sets that you could consider using, links to information on previous competitions. In particular, there's a link to a recording that we made last year to launch the Wimbledon prediction competition, where the winners, two of the winners from the Euros prediction competition, spoke about what methods they'd use. So again, really relevant because we were talking about predicting football results, and today we're going to talk about maybe if you would need to do any tweaks because we've got women playing the game this time. Right, so that's everything from me. If you've got any questions, that's brilliant. Do bob them in the chat, and after the presentation on modelling women's football scores, we'll have a big Q&A where we'll answer all your questions to the speakers or about the competition. So do put any questions you've got about the competition in the chat. As I say, that'll be the point when I add the link to the GitHub address, because I don't want you missing a second of this presentation that we're about to have. So without further ado then, I'll hand over to our fantastic speakers who are going to talk about modelling women's football scores. So I'll stop my share and let them take over.
First of all, thank you, Jessica, for inviting us and having us here, and for the very nice introduction. I would briefly like to introduce myself, then hand it over to Marius. So my name is Rouven Michels. I'm a PhD student from Bielefeld University under the supervision of Roland Langrock. And my research deals about sports analytics, also related to hidden Markov models, although this topic here is not related to hidden Markov models. But yeah, and yeah, we're very glad to talk about modeling women's football scores today. But before that, I would like to hand over to Marius.
Yeah, thanks, Rouven, and hello also from my side. And yeah, thanks for the introduction, and thanks for the invitation and for this opportunity to present our work here today on modeling women's football scores. So this talk will be based on a joint paper from Rouven and mine, together with Dimitris Kalis from Athens University. And when we started with that project and looking into modeling women's football scores, we found that there are some special patterns in the data. Some are quite challenging, which led to actually a very nice and fun project. And in the next 20 to 30 minutes, I will take over the first part and talk about some special patterns in the data, and then I will hand over to Rouven, who will present the models that we developed. Okay, so in recent years, the attendance and the general interest in women's football really increased. So if you follow the domestic women's football leagues, there's been an increasing number in the attendance in recent years. But last year there was some sort of highlight in summer. There was the Euro Championship, so the Women's Euro Championship held in England. And actually last year when we met at the Math Sport conference that was held in Reading, we went to one of the matches. I think it was Germany against Spain at one evening, and the stadium was sold out. And this actually applied to many of the matches from the UEFA Euro Championship last year. And this photo here was taken at the final in the Wembley Stadium, where almost 90,000 people attended that match. So there's been really an increasing interest in women's football. But when it comes to modeling women's football, or modeling the score lines or the number of goals, in women's football, of course, there has been lots of work been done already before on how to model the number of goals scored in a football match in general. So not only applicable to women's football, but of course also to men's football. There has been lots of work done, starting basically in 1982 with a paper by Marius, who used a double Poisson model, almost a bit more than 10 years, like 15 to 20 years after that, there were some papers on introducing a correlation, because the double Poisson model, you just assume in the double Poisson model the Poisson distribution for the goals scored by the home team and for the goals scored by the away team, and to account also for some potential dependence between the goals scored by the home and away team. In the paper published in 1997 by Dixon and Coles, they developed some kind of special structure of dependence. This is something that we will also take, or where we're going to take a deeper look at in a few minutes. And Kalis and Notsufras in 2003, they proposed the bivariate Poisson distribution and had an extra parameter for the correlation between the home and away goals. And when talking about like correlation or dependence in general between home and away goals, there are also of course copular models available that have been used in the literature. And in 2017, there was also a paper by Boshnikov and co-authors who used a special form of the Weibull distribution, so a Weibull count distribution to model the number of goals scored in a football match. But before we start with talking about the models, let's have a look at the data first, and especially with a focus on the differences between men's and women's football when it comes to the scoreline. So what you see here on this slide is the absolute difference in the final score for women's and men's matches. So these data were sampled from the German Bundesliga, so from the women's Bundesliga and for the men's Bundesliga for the last 5 years. And here you see for different differences in the final scoreline, the corresponding proportion. And what we see here, so if we compare like the first row in the left and in the right table, we see that a win or a victory by one team with a margin of only one goal is more common to occur in men's football compared to women's football. And also a win by 2 goals is more common in men's football than in women's football. But if we look at these larger difference in the final scoreline, so wins by 5 or 6 or 7 or even more goals, we see that these occur way more often in women's football compared to men's football. So this is like a first indication that that there are some kind of differences in the scoreline, in the sense that like these more extreme results where one team is winning by 5 or 6 or 7 or even more goals, this occurs more often in women's football than in men's football. And when we take a look further at the dependence between these quantities, so between the home and away goals, here on this slide, so what you see here, for example, at the bottom left, the 0.46 for the 0-0, so for the scoreless draw. What we did here was simply to count in our data how many 0-0s do we observe and divide that by the product of the marginals. So we then simply count how often does the away team score no goals, how often does the home team score no goals, and then we take the product of this and then we divide the joint frequency of the 0-0 divided by the product of the marginals. And if this value is close to 1, so it doesn't have to be exactly 1, but close to 1, then this indicates that the home and away goals are independent of each other. But if we look at some of these, for some of these scores, so for example, for the 0-3 or 0-4, or for the other way around, if the home team scores 3 or 4 goals and the away team scores no goals, we see that these numbers are much larger than 0, which indicates that these scores are not independent of each other. So there's an overrepresentation of these scores, so like 3-0 or 4-0, and a clear underrepresentation of these scoreless draws. But if we look at these tables, so this was calculated for women's football scorelines, and if we compare that to what we observe for the men's data, we can take a look at in the literature. And in this paper by Dixon and Coles in 1997, they actually start their analysis with such a table. So the numbers that you see here in this table, so this is just a screenshot from their paper. And what you see here, this is actually the same summary statistics that you have seen on the previous slide, just multiplied by 100. And what they found was that the draws, so the 0-0 and the 1-1, that these are overrepresented in the data. And this is especially for these scoreless draws, this is like exactly the opposite way what we have in women's football. So in women's football, we have an underrepresentation of 0-0s, while this score is overrepresented in men's football. So the first thing that we can summarize here is that the type of dependence between home and away goals is different for men's compared to women's football. So this is like the first exploratory finding here in our data. And when talking about independence, we can also take a look at the correlation between home and away goals. So what you see here are for the 4 major European football leagues, so for the major European football leagues for women's football, always for the first leagues in England, Germany, France, and Spain. For each season, the empirical correlation between the number of goals scored by the home team and the number of goals scored by the away team. And 1 dot here represents one season. And we see, if we take a look to the right, that actually only in 2 seasons in England, actually, there we have a positive correlation. And in all other seasons, and also for all the other countries, we observe a quite substantial negative correlation between the goals scored by the home and by the away team. And the second dashed line, so this bit of a thicker dashed line, this indicates the correlation that can be implied by the model by Dixon and Coles. So Dixon and Coles, they applied their model to men's football, where the correlation is often close to 0, but it's also often slightly positive. And in fact, their model can only allow for a correlation that is slightly smaller than 0. So this does not really fit to our data, because here in women's football you often observe a substantial amount of negative correlation. So this is also one of the key findings here in our data, that we have a negative correlation. And we also have a third finding, which is summarized here on this slide, where we again, for these 4 leagues in England, Germany, France, and Spain, plot for all teams and in all seasons the mean and the variance in the number of goals scored. And what we see here is that while for some leagues it seems that for some point it seems that the mean is equal to the variance. So this dark blue line and these light blue lines, they indicate confidence intervals. But we see that many observations actually they fall out of this range. So it seems to be that over dispersion, so where the variance is larger than the mean, that this is a problem, or that this is actually also a finding here in our data, or one of the key patterns that have to be taken into account when we formulate the model. So these were like the main 3 points that we found when we started working with these data and started to build models for modeling the score lines of women's matches. And up next, we will start with the modeling, and we will start with the Dixon and Coles model. So the paper we already mentioned before, it's a highly influential paper, and the idea what they use, it's actually quite simple and I think easy to follow, because what they found in their paper, what we have seen in this table, what we have seen on one of the previous slides, was that in men's football we have an overrepresentation of 0-0s and 1-1s. And Dixon and Coles, they with their approach, they actually wanted to tackle this problem. So what they did, they formulated a PMF, which is basically the product of two PMFs of the Poisson distribution. So they assume a Poisson distribution for the home goals, a Poisson distribution for the away goals. And then there's this function tau. And with this function tau, they modify the probabilities, but only the probabilities between the 0-0 and the 1-1. So only for these four scores, they shift the probabilities basically to adjust these overrepresentation of 0-0s and 1-1s. And for the remaining scores, so for all other scores like 2-1, 2-2, and so on, they simply assume independence and just build the probability by multiplying the marginal distributions. And this is actually this was the starting point of our work, like building up on this model and also on the ideas that Dixon and Coles proposed. And with that, I will hand over to Rouven.
Yeah, thank you, Marius. As Marius mentioned, that was a starting point. And at the starting point, we thought about, okay, how can we embed this function? And what we found is the so-called Sarmanov family of distributions, where we can formulate the Dixon and Coles model as a special case. Because in the Sarmanov family of distributions, we collect all probability mass functions, pi here, for I equal to 1 and 2 as a bivariate function, and all functions qi such that they fulfill this condition. So such that the expected value of this qi function is equal to 0. And if we fulfill this, so for the PMF and the q function, then Sarmanov says that we can define probability mass functions with the marginals here, P1 and P2, times 1 plus some dependence parameter times these q functions of the respective marginals. And this can look a little bit complicated at first, but if we define our first q function as this function here, like this is minus lambda as the parameter of the Poisson distribution for x equal to 0, and 1 for x equal to 1, and 0 for the rest, we end up with the Dixon and Coles model. And with that, we found the first model in our Sarmanov family. And as Marius mentioned, we have some properties which we saw in the data, so we can fill this gap here in the Sarmanov family based on what we have seen at Dixon and Coles, or in the Dixon and Coles model. And the first point we would like to start with is to change the intensity of weights. So if we look here at this second q function, we named it q bar, then we can see here that we have a quadratic factor and here a linear factor, but still only change probabilities up to 1. And visually, we can see this here in the top plot, where we can see that the 1-1 and the 0-0 are stressed a little bit more than in the classical Dixon and Coles. However, we saw that we maybe have to shift also probabilities in women's football, not only for 0 and 1. And thus, we decided to extend this further up to a finite number. And this finite number I just call here S. And with using this QS function, we can see here in the middle plot for the special case of S equal to 2, that we cannot only change probabilities for 0 and 1 now, but also for 0, 1, and 2. As you can see here, a very bold and very stressed probability for the 2, 2. Beside this, we would like to give you insight that it is not only possible to choose the Q functions for x1 and x2, but we can just do it also separately. For example, it's also possible that for the first margin, we use such a Q2 function, this Q function up to 2, and for the other way. And for the other margin, we use the Dixon and Coles Q function, which then leads to such an asymmetric plot here. But it could be the case that for some constellations of data, this might be a preferable model choosing not the same marginals. However, we saw in Marius' presentations that we have some overdispersion in the data. And until now, we just applied the Poisson distribution, which does not really fit because it assumes, like you all know, that the mean should be equal to the variance. And with that in mind, we changed the marginals the first time. And here we changed to a negative binomial marginal to have a parameter for the overdispersion. And if we do this, the first step was to like recreate a Dixon and Coates model for negative binomial marginals, which you can see here. So like you will recognize this one for the case that x is equal to 1 and 0 for the rest. And also this plot looks similar to the Dixon and Coates model with Poisson marginals. But also we can see that in comparison to the independence model, which is here called as the double negative binomial, where we just assume independence between the marginals, that we again can stress here the diagonal or the other way around when having this dependence factor a negative. Also, it's possible to stress the off diagonals. Starting from this, so starting from this finite shifts, we can also shift probabilities across the entire support. So we're not only, it's not only possible to say like, okay, we are going to some finite number S where we shift probabilities, but it might be easier to let the model decide in such a way to how far it would like to adapt probabilities. And thus we also looked in the literature, and we found a Simonoff function for the entire support, which uses a Laplace transform evaluated at S equal to 1. And the evaluation took place by, now it's getting complicated, Lakshminarayana for Poisson marginals and from Farmonier for negative binomial marginals. And based on their work, we then generalized the negative binomial case. So we generalized the Q Simonoff functions with a Laplace transform for negative binomial marginals and called it the alternative negative binomial Simonoff model. So in short, the ANS model, where Q mu denotes the mean. So we used some reparameterization to later on compare the mean of the negative binomial with the mean of the Poisson distribution, and also here the variance of the negative binomial distribution. And we just had to calculate this rather complicated constant, but also depending on phi and mu, such that we fulfill the equation from the beginning, which I told you that the expected value of this function is equal to 0 given the marginals. And when comparing these last two Q function, which fulfill the property to shift probabilities across the entire support, we can see here in this plot that the ANS function is a little bit more smoothly in such a way that it still gives probabilities here to the 0,0 case for the same parameters we used here. But also when we would compare it to previous models, gives more weight here to the higher wins in the case of women's scores. And to the case of women's scores, I would now like to go and apply these models to women's football data, in particular to the women's football scores for the first divisions in England, Germany, France, and Spain from 2011 on. We left here out the COVID season or the COVID seasons because they have well, probably you will know some other structures somehow. And what we used is linear predictors, where we included a home advantage, and we included an attacking and a defensive parameter for each the home team, here denoted by HJ, and also by the away team, denoted by GJ, and here for the defensive and the attacking parameter. And then we model the mean of the home and away teams of the chosen distribution, and that is why we also use this reparameterization, because we now we can compare the Poissons and the negative binomial models simultaneously. And if we do this, we can see here that so we see here the AIC results. And if we compare that across the leagues, we can see that in England, the extended Dixon and Coles Poisson model with up to 2 is preferred by the ASC, which somehow fits to what we have seen in the exploratory data analysis by Marius, where we saw that England might have or had some seasons with slightly positive correlation. Maybe we do not need this clear negative correlation here. And we also saw that the overdispersion was not too high in England. But in the other leagues, we saw that the data prefers the ANS model, so prefers our newly generated and generalized model clearly here. And to confirm this, we then did some model checking. How did we do this? So we fitted the ANS model to the first 2/3 of the last full season in Germany. And then afterwards, we evaluated the predicted performance based on the remaining match days. So you can see here at the darker blue dots are the true points at the end of the season. And the light blue areas here are the 95% confidence intervals, which we came up with in the Monte Carlo simulation using our model. And what we are seeing is that our confidence intervals include all the dots, which gave us a quite good impression that our model also works for predictions. And with that, I would like to conclude or go into the discussion. So what we have seen? We have seen that the Dixon and Coates model is a part of a wider family called the Salmonov family of distributions. And based on this construct, so to say, we can extend this model and allow for more flexibility. And among these models, we found the so-called ANS model, which is much more realistic for women's football than the commonly used Dixon and Coates model for men's football. And to go one step further, we thought about, okay, what's future research? So the first thing is, like always, we could include further covariates, which is kind of difficult in women's football because the market values, so in men's football, mostly people use the transfer market values. However, they come from like this website, which do not exist like in women's football, and thus the possible market values wouldn't be that reliable maybe. But we also could account for the current form. Another thing is that we could use a weighted time component to account for the team's development, and we could further on use our models for the prediction, and especially for, like we are here to get today, for the RSS prediction of the upcoming FIFA Women's World Cup. We could do this, and surprisingly, we also did this. So this is our tournament prediction here, where we also used a time-weighted component. So this other point of the current research we already implement here. So this is like our today's work, so to say. And with that, we have the strong favorites, the Spain and the US for the upcoming World Cup, with England and France at position 3 and 4, and at the 5th position is Germany with a chance of 5% of winning this tournament. With that, I would like to just briefly give you our references. So our paper, this is a paper, like Marius mentioned, from with Marius and Dimitris Kalis from Athens University, and we have this on arXiv. And with this, I would like to thank you for your attention, and feel free to ask the questions you would like to ask.
Brilliant. Thank you so much for that. I'm giving you Zoom applause. So thank you. With that, we'll open it up for questions. So remember, if you've got any questions about the competition, you can bob those in the chat. If you've got any questions that you'd like to ask our speakers, bob them in the chat. Or if you're feeling brave and want to be part of the recording, then raise your hand And it'd be even better if you want to ask your question yourself rather than me reading that out loud for you. So while you're typing away, I've been storing up lots of questions that I want to ask you. So I'll kick off. Pun intended. So the very start of your presentation, when you're talking about, well, it starts with the Dixon Coles, doesn't it? And then realising that actually Poisson might not represent the actual scorelines that you see in football. And then you're sort of saying that in women's football, there are more lopsided results. So my first question is, do you think that there'd be a difference between all the work that you've done was on the leagues, the different leagues? Would there be a difference for international football? Because you do tend to see, and in the men's game as well, you do tend to see more lopsided results at international level where you've got perhaps professionals playing against amateurs or semi-professionals, as I say, even in the men's game. So that's my first question. Do you think there'd be a difference for your very final thing, which was doing the World Cup? Do you think there'd be a difference actually for international football?
Mm-hmm. Yeah, so I think for the larger men's tournaments, so for the World Cup, for example, I think there are also like always plans to from the FIFA to extend the World Cup to have more teams, which then may lead to some more lopsided matches. So in general, I think we also have that in men's football. So we did not check that in the data, but just from our work, I'd say, or I would expect that we also see that in men's football, but especially for the upcoming women's football World Cup, I think there we have also many lopsided matches. Something like I think the US are in one group, I think with Vietnam or Haiti. So it's so they are also very lopsided matches. What we also saw then in our estimates and when building the predictions. So I think the highest prediction for the win of one team, I think it was for some match for the US, where our model predicted a probability of, I think, 99% So there we also on an international level we have very many lopsided matches. But with the upcoming World Cup, of course, there are also some groups where the difference in the team's quality is not that large. So where there's a smaller variance in the team's quality.
Yeah, thanks. So I agree with you. I think that in men's football, you would see that in the qualification stage when you've got, we always have, don't we, playing against some people, and it's always nice to say, these people are decorators in their real job. So I think you see that in qualification, but not at the tournament stage so much in the men's game. Whereas in the women's game, you certainly do get those amateur sides or semi-professional sides making it to the tournament. Similarly, this is something that we picked up on in the previous webinar. So if you've not seen it, go over to the RSS YouTube channel and watch it, which was actually, so when we're talking about doing international football, there's less information. When you're trying to model a league, you know that they're going to play each other twice, home and away. You might get promotion and relegation that makes things a little bit difficult, but you sort of have more information there. Whereas in international football, there's less instances of playing certain teams, particularly at a World Cup, because there really isn't a lot of data on people playing outside of continents, because you have, even in qualification for a World Cup, you're qualifying in your continent. So yes, do you think there's any challenges particularly with trying to predict a World Cup and sort of, like I say, lack of data there, or like we were saying in the last webinar, there's kind of networks inside the data?
So I think definitely it's more difficult, but I think also an advantage of our model is like there are two ways, for example, to introduce correlation. The first one is to use covariates, which introduce the correlation by itself, by the structure between the covariates and by the model itself. And what we are doing here is like we use the model to induce the correlation, which has the advantage that we do not need the correlates to have, for example, this correlation. And yeah, as you mentioned, first of all, for international matches and also for the World Cups, the data is sparse. But especially for women's football, also for this leagues, as I mentioned, with the market values. So for men's football, you have market values which are based on wisdom of the crowd up until the, I don't know, third, fourth league. Even for youth players, I think you have these market values. For women's football, this is not existent. I think there's a page which has some market values estimated for women's players, but they are very specific, and well, probably you cannot really rely on this. So this is kind of advantage of our model. But yes, in general, also a World Cup is much more difficult. Also, when you think about knockout phase, I mean, modeling 90 minutes and then modeling 30 minutes and then modeling the penalty kick out, this brings up a lot of questions. Yeah.
Yeah, thank you. Fantastic. Really interesting answer. Because that's something when we were thinking about, which competition to choose this year, which tournament to choose to predict, that was something that we thought would be interesting, this idea that we've done football before. So a bit exactly like your talk was, would you need to tweak something that you'd done if you'd entered the last the Euro 2020 competition? Would you tweak it, or could it just run with different data but for women? So as I say, your talk was really interesting on that. But that was another aspect that we thought. So is there an intrinsic difference in the actual results? But actually, the things that you can use, your data sources and things like that, there's differences. There's definitely a gender data gap as well. I've had a question come in through the chat, so I shall definitely ask that. Thank you so much for asking this. So someone's asking, from your finding, is there a variation in home advantage among different teams in women's football?
Yeah, thanks for that point. Thanks for the question. So actually, that's not something that we investigated. So for the model for modeling the women's football scores for the different domestic leagues, we fitted one model to each season, but the home parameter this was constant, or we assumed it to be constant across the teams. So what we can say is that there is definitely a home advantage in terms of magnitude. It's not as large as for the men's game, but there's a home advantage. I think this was also discussed during the I don't know, maybe it was this year's or last year's Math Sport conference, where followed a talk about scheduling, and then there was a talk about scheduling a women's league, and one argument there was that there is no real home advantage, but actually according to our results there's a home advantage. It's not as large as in men's football, but there's some. But here we kept it a bit more simple and assumed that this home advantage is constant within one league across all teams. And what we implicitly also assume is that it's constant across time. So it may be the case that now, since women's football is becoming more popular, more people are attending matches of women's leagues, and this may also have some effect on the home advantage. So it may be the case that the home advantage today is maybe it's larger than 5 years ago or 10 years ago, but this is something that we have not investigated yet. But I think that's super interesting to see. So that would be really interesting to see how the home advantage evolved over time, and if there are differences across the leagues. And also across the teams,
Yeah, great question, really great question. And like you were saying, at Math Sport conferences and things, there's a lot of discussion about home advantage and what is responsible for home advantage. And again, I noticed in your data set you missed out the COVID seasons for various reasons, but one of which is that home advantage would be very different in that season. I saw a really good paper that was talking about home advantage in the COVID pandemic with the restrictions in the German leagues, and they were saying that actually the difference in home advantage in the lower leagues, they couldn't really see it too much in the restrictions, and that does go towards what you're saying there, that it's fan numbers and how many people you're normally getting to the matches. If they all of a sudden don't come anymore, obviously that's going to have a bigger impact if you're in the Bundesliga as opposed to a lower league. So yeah, really, really interesting point, and lots of things to think about. And there's also the travel fatigue as well. because that's something that's been lots in the news recently, about WNBA teams, so women basketball teams in America, that when they're playing each other, so you're flying across America and they're on standard flights like I might get, waiting in airports, sleeping on benches and things, as opposed to the male NBA players who've got private jets for their teams. So lots of things that could mean that this would be different for men and women. But so you've taken it league specific, but fixed it. And again, there's been lots of work in the men's game on that, but maybe not so much on the women's game. So fantastic question. I think we've got 1 more minute, so there's just one more question that's come in the chat that I think we might have time to ask. So let me just read it. Okay, interesting. Yeah. So this person's saying that you went with the negative binomial when you were sort of saying not the Poisson, let's try negative binomial. What was your reason for that? Because when we saw in the sort of, you give us the nice history of all the modelling of men's football, and the latest one was the Weibel or the Bible. Never know how you say that. So what made you go for negative binomial?
Correct me, Marius, but I think it was just that we thought about this over dispersion, and like this over dispersion factor or parameter, which is in the negative binomial, and also the work which has been done by Famoyer in the Samanov family, which we could build upon and build upon this ANS model, and it worked quite well. Yeah.
Yeah, but so the Samanov family with the basic model for formulation, it could also be then used for other distributions. So we started with Poisson, and we went then for negative binomial because of the over dispersion. But one could also include other discrete distributions, or the PMFs of other discrete distributions. That's also possible.
Brilliant, thank you, and thank you. That was a great question. Thank you very much. So, without wanting to put anybody on the spot, I just wanted to let SmartOdds, so like I said before, they're the sponsors of the competition, give a fantastic presentation last week. So, like I say, do watch the recording if you didn't manage to make it. That was really linked to all the things that have been said today. So, I just wanted to give you a chance, SmartOdds, to ask if you had a question or anything you wanted to say about that presentation. Hopefully you can unmute yourself.
Can I pretend I can't? I don't have a question ready, so I will just take the opportunity to thank the speakers for a very, very interesting presentation, which really did tie in with some of the concepts we discussed in our bit. To do with looking for evidence of over dispersion from a model versus from the aggregate counts, and I will leave it at that. So thank you very much.
Thank you. Sorry for putting you on the spot.
Quite all right.
Ian's unmuted. Have you got anything to add, Ian?
Only that I thought the technique for generalizing the count distribution was very interesting.
Yeah, absolutely. So yeah, fantastic talk. And as I say, I saw this at the MathSport conference, and we were thinking about this competition, and it was just exactly going to the question that we were sort of wanting to investigate with this competition. So absolutely agree. Really, really interesting, and really fantastic presentation. Thank you very much. Right, we're getting towards the end of the hour, so I don't want to take any longer than we're allowed. So all I'll do is I'm going to put that link to the GitHub site, the page for this year's prediction competition, in the chat there. And I really would encourage people to enter. I'll let you in on a secret. I only started thinking about this yesterday. So really actually coding stuff up yesterday. So there absolutely is enough time. Again, if you watch the videos from our previous winners, you'll see that they're saying they spent about a day on it. So we have definitely got time before the tournament kicks off to get an entry in, especially if you are a student. That includes PhD students. So if you get e-student membership of the RSS, which I believe is free and reliably informed, so please consider entering if you are a student, because there's a good chance that you would end up winning and presenting at the RSS conference, which would be a fantastic prize. It'd be fantastic to see you. So please encourage everyone to enter, especially students. If you're not an e-student member already, then that's simple enough to sign up for. I've actually had an email from somebody from an entry already that's saying, your pitch worked, I have signed up to be an e-student member, so I can enter for that prize now. So I'm reliably informed that all works as it should do. So thanks again to everybody who's attended today. Brilliant numbers, that's great to see. Thanks for anybody who's watching this in the future, for taking the time to watch this. Thanks to Smart Odds, the sponsors of our competition, for adding their insight as well. And then, of course, thanks to our two fantastic speakers that gave a really, really interesting talk. And I'm seeing things in the chat saying, really presentation, really interesting. And that's just going towards what Smart Odds was saying as well. So thanks everyone for coming. Watch this space. The recordings will be shared as soon as they're ready by the RSS web team. So thank you all for coming.